Hello everyone. Today I would like to share our contribution to the Haystack open source ecosystem. Over the past few months, our team has been working on bringing native IBM Db2 support to Haystack, allowing developers to use Db2 as a vector store for retrieval augmented generation applications. So in this session, I'll briefly introduce Haystack, explain what we have built, walk through the architecture, demonstrate how it works, and discuss the kinds of enterprise AI applications that this integration enables. Before diving into our contribution, let's spend a minute understanding Haystack. Haystack is an open source Python framework designed for building production-ready AI applications such as retrieval augmented generation, semantic search, and AI agents. Unlike visual workflow tools, Haystack follows a code-first approach. Developers build reusable Python pipelines, making applications easier to test, version, and deploy. A typical Haystack pipeline starts by loading documents, converting them into embeddings, retrieving the most relevant information, and finally passing that context to an LLM to generate the grounded responses. So this modular architecture makes it easy to swap components without redesigning the entire application. With that background, let's look at our contribution. IBM Db2 recently introduced native vector data type support in IBM Db2 12.1.2 and above. We wanted developers using Haystack to take advantage of this capability without requiring a separate vector database. To achieve this, we contributed a new integration package called IBM DB Haystack. The contribution consists of two primary components. First is IBM Db2 Document Store, which stores documents and their vector embeddings directly inside Db2. It automatically creates the required table, so developers don't have to write any database schema manually. The second is IBM Db2 Embedding Retriever, which performs efficient vector similarity search while also supporting metadata filtering, compound conditions, and date-based filtering within the same query. Together, these components allow Db2 to function as a fully native vector store inside Haystack. Our goal wasn't simply to store vectors in Db2. We wanted developers to have an experience comparable to other production vector databases. Beyond storing vectors, this integration is designed for real-world AI applications. It supports multiple similarity metrics, advanced metadata filtering, automatic table creation, and a model-agnostic pipeline. That means whether you are using watsonx, OpenAI, Gemini, or Hugging Face models, the same document store and retriever can be reused without modification. So the integration enables a wide range of AI applications, including RAG pipelines, semantic search that retrieves information based on meaning rather than keywords, and enterprise chatbots capable of answering questions. Beyond conversational AI, it supports governed enterprise assistants where metadata filters enforce business policies, and it can also serve as a retrieval tool within more advanced agentic workflows. Under the hood, the workflow is pretty much straightforward. We connect to the IBM Db2 through the IBM Db2 Document Store. Documents are then processed by an embedding model. So in this example, we are using a watsonx embedder, but any supporting embedding model can be used. The generated embeddings, along with the document content and metadata, are stored directly inside Db2. When a user submits a query, the query is embedded in the same vector space. IBM Db2 Embedding Retriever performs the vector similarity search directly against the stored embeddings while applying any metadata filters. The retrieved documents, the top K documents, are then passed into the prompt builder and finally to the LLM, which generates a grounded answer. So one important advantage of this design is that developers can freely replace the embedding model or the language model without changing the overall pipeline architecture. This diagram shows the complete end-to-end architecture of our integration, from user query to a grounded response. It also highlights how the Haystack components interact with IBM Db2 behind the scenes. So in the next slide, we'll walk through this workflow step by step. Now, let's see the integration in action. We have built a banking assistant powered by IBM Db2 and Haystack. So when a customer asks a question, for example, asking about the transaction limits, the retriever performs the vector similarity search, applies metadata filters, and returns the most relevant documents. So those documents become the context for the LLM, allowing it to generate a grounded answer rather than relying solely on the pre-trained knowledge. So we'll walk through the live demonstration in the next slide.
Hi everyone, so today I will be quickly demonstrate you how you can create your banking assistant example using Haystack and IBM Db2. So let's start with the demonstration. Let me just run this example I have created, which is around 130 lines of code only. So here we will be demonstrating the connection, the ingestion, the rec pipeline creation, and you will ask some queries and filter that with the help of the metadata. Then let me just run it. Once you run, it will start connecting to the IBM Db2 on the basis of the credential you have provided over there in the connect function. You can see. So here I am using the file machine for connecting with Db2 here. Then once we are done, then it will start the function that store document. So it will calculate the embeddings for you and store the embeddings into your IBM Db2 Vector Store. Once the embedding storage is done, then you basically building a rec pipeline over there. It will basically, first of all, create the component. It will add the component. So basically the pipeline is created. Once the pipeline is created, we will connect the component with each other. So which is the actual flow of Haystack. You will first of all add the component to the pipeline, then you will connect them together with the input and output. Once you are done, then you will basically asking a query over there. We are asking a query here. What saving account do you offer? So once this query is asked, it will generate the top K. It will retrieve the top K element from the vector store, which is similar to this query, and the LLM will generate. The LLM over there I am using is Granite 3.38B model, which is the IBM model. So you can also use the Watsonx as well. It's also available inside Haystack. So it will generate a response for you easily. You can see the response over there. It's coming from the LLM directly, as vector store is having the context about it. So it is LLM is using the same context over there. Now let's demonstrate the metadata filtering. So here, instead of semantic search, we simply search the metadata. We filter document tagged as a security related, and Db2 returns the matching it got directly into the production application. So here the metadata filtering and vector search and combine and improve the retrieval quality. So that's the complete flow from the documentation, the indexing to grounded answer generation, and the metadata filtering, all built with Haystack standard component on the top of IBM Db2.
While we have demonstrated this with a banking assistant, the same integration can power enterprise knowledge search, customer support automation, policy and compliance retrieval, and agentic AI assistants. To help you get started, we have included the key resources on this slide. Thank you for your time.